All right, so in this video, I want to talk about derivatives and continuity. Specifically, there is a relationship that I want to kind of expand upon with differentiation and continuity. I also want to be able to identify functions where the derivative does not exist. So before I do that, I want to mention to you just a recap stuff and information that we need to review from previous videos. First and foremost, the derivative just represents the slope of the tangent line or the slope of the function. We can write it as f prime of x, which is f with an apostrophe, or we can write it as dy dx. That's just saying the change in y divided by the change in x. We have two formulas. The first one is specifically used to try to find the derivative at a point. It's f of x minus f of a divided by x minus a, and we take the limit as x goes to a. The second one is the one that involves the difference quotient, which is f of x plus h minus f of x divided by h, and the limit as h goes to 0. Now, again, these are our formulas. They're very, very helpful to have memorized, so please make sure you try to memorize them. Now, moving on. I'm going to talk about the two words differentiable and differentiation. Differentiation refers to the process of actually finding the derivative, okay? So that's an important thing to remember is the derivative is my answer, differentiation is the process. If I say something is differentiable, notice the word able at the end, that's my little suffix there. It's telling me that I'm able to find a derivative at a specific point or of that function. Okay. So these are very important words to make sure you recognize and have in your vocabulary in calculus. That being said, I want to go ahead and move on to the two true or false questions written down here in green. The first one says, if a function is differentiable, then the function is continuous. Now I'm going to go ahead and mention to you that this is always true. So if we know that a function has a derivative or is differentiable at a point, then the function is always going to be continuous. We know that that's absolutely 100% true. However, the converse of this statement, if a function is continuous, then the function is differentiable, is not always true. So I'm going to write the word false for that. So again, just because it's continuous doesn't mean it's differentiable. That's what I'm going to get to in my examples in this set of notes. I do want to mention, though, is if a function is not continuous, this is important to make sure you think about. If a function is not continuous, then it's not going to have a derivative at that point. Okay? So that's, again, an important thing to think about. If the function is not continuous, then it's also going to be not differentiable, at least specifically at that point. Wherever it's discontinuous, it's not going to be differentiable. So now that I've got that said, I'm going to go ahead and move on to my examples. And I've got three of them here. And I'm going to focus specifically on x equals 0 for all of these. Now, I do want to point out, I went ahead and graphed all these. The first one is y equals absolute value of x. Notice it is continuous um, at x equals 0. Because if I check the limit as x approaches 0 from both sides, that does give me the same answer as if I plugged in 0. So notice on the left side, it's headed toward 0. If I look at the right side, it's headed toward 0. And if I look at the value, it's 0. And that's the same thing with all three of these, is they're all three continuous at x equals 0. And that's, again, very important thing to think about is notice all of these, if I look, no matter which direction I'm going, I'm always headed toward essentially the origin, 0, 0. But that being said, notice again, absolute value function goes through 0, 0, 1, 1, 1, negative 1, 2, 2, negative 2, 2, 3, 3, negative 3, 3. So we're looking at those points. Now, what I want to go ahead and kind of elaborate on real quickly is if I were to imagine trying to find the derivative here, again, we're looking at 0, 0. What happens if I actually just plug in some numbers and try to find the slope between those 2 points? Just kind of like what we were doing with the whole process of finding a derivative. So let's try if I plugged in negative 1. If I plugged in negative 1 into the absolute values, we would get positive 1. So my slope formula would be 0 minus 1, because again, y values are on top, and 0 minus negative 1. So 0 minus 1 gives me negative 1 over 0 minus negative 1 gives me positive 1. So my slope there is at negative 1. Even if I picked a number that was really close to 0, like negative 0.1, we would get positive 0.1, and it would work out the same way. So 0 minus 0.1 over 0 minus negative 0.1. We would end up actually getting the exact same answer for all of these, which is kind of interesting about doing this absolute value function. However, what happens if I test instead some positive numbers? Well, if I plug in zero point 0.1, I get zero point 0.1. If I plug in positive 1, I get positive 1. But when I go to do my slope formula, notice in the denominator, it's no longer minus a negative. Now it's just minus a positive. So we get negative zero point 0.1 divided by negative zero point 0.1, or even if I did the other one, I'd do 0 minus 1 divided by 0 minus 1. I get negative 1 over negative 1. So instead of getting a negative answer here, we get positive 1 as our final answer. So what I mean by that is on this left side, the slope is always negative 1. And on this right side, the slope is always positive 1. Okay? So the question is, what happens here at 0? Well, it just kind of stops, changes directions. It's not a smooth curve. It just, it's very much like a corner. And that's actually how I'm going to refer to it, is x equals 0 is a corner point. Because in this situation, what's actually happening is it's hitting 0, stopping, turning, and going in a different direction. And this would be exactly why, in this case, the limit does not exist, because it's going from negative 1 to positive 1 right there, and it's immediately. It's not a smooth transition. It's just an immediate jump. Okay, and again, that's the word I'm gonna key in on there, is it's not smooth. It's a corner point. Corner point being the vocabulary word that I'm trying to emphasize there. Um, so again, if you think about a parabola is very similar to the absolute value of x, because it's decreasing on one side and increasing on the other, but the difference is the parabola is actually smooth. So again, absolute value is not smooth. It has a corner point there, and that's why it's not differentiable. I'm going to try something very similar here with this x to the 2/3. Now, I will warn you that this is the same thing as the cube root of x squared. So if I plugged in positive 1, I get positive 1. If I plug in negative 1, I get positive 1 again. So let me, again, just kind of approach this perspective. And I'm going to try plugging in a couple of numbers that are really, really close to 0, just to prove my point. I'm not going to write down my whole slope formula this time just because it's going to get kind of messy. So let me go ahead and find these y values real quick. So if I do negative 0.1 to the 2/3, we get 0.215443469. Notice this does have a little bit of symmetry here, so even if you plugged in the positive, you would still get the same answer. And if I were to plug in, let's do that, negative 0.001 to the 2/3 and positive 0.001 to the 2/3, we actually get 0.01 and 0.01. So if I do my slope formula with these numbers, I want to show you what I get. So very similar to the absolute value here, we would do 0 minus 1 over 0 minus negative 1, and we would get negative 1 over 1, which is just negative 1. If I did this with positive 1, we would get positive 1. So let me go ahead and show you real quickly what happens when I try some of these other numbers. So if I do negative 0.01, we're going to do 0 minus that 0.2154439 answer. Excuse me. So let me do that. 0 minus that answer divided by 0 minus negative 0.1. I get an answer of negative 2.15443469 as my answer. But if I did it with the positive, I actually get positive 2.14 or 15443469. And the question is, what happens if I do the other one? So if I do 0 minus 0.01 divided by 0 minus negative 0.001, we get negative 10, and this is actually positive 10. If you tested more numbers, what you would hopefully see is that on this left side, we have these negative numbers. They actually get really big really fast. So we've got negative 1, negative 2.15, and then negative 10. That's headed toward negative infinity. But if I check the other side, the right side, it goes 1, 2.15, and then 10. So this side is headed toward positive infinity. So let me go ahead and make sure I mention to you is, number one, the important thing here is these limits are headed toward infinity, so they are not numbers, and they do not exist because I'm looking for slope. I'm looking for an actual number here to describe how steep this thing is. Well, infinity is not a number, so it's not a good answer for slope. So what I'm going to call this actually has another special name. This is called a cusp. C-U-S-P. It's called a cusp. It switches, in this case, from negative infinity to positive infinity, or it could switch from positive infinity to negative infinity. Either way you look at it, infinity is not a number, not going to be a good answer. Now, I'm going to go ahead and talk about this last one here. So this last one here is the cube root of 8x. And again, I'm just going to kind of follow the same process. I'm going to just show you real quickly. -1, let me do -0.1. We'll do, actually, I'm not even going to test any others. I'm going to do 0.1 and I'm going to do 1. If I plug in 1, I know I get 2. If I plug in -1, I get -2. Let's do these others real quick. -0.1 times 8, and then I cube root it, and I get -0.430886938. And if I plugged in 0.1, I get the positive version of that. All right, and what happens when I go to try to find slope here? All right, so let's see. If I do 0 minus -2 divided by 0 minus -1, we get a slope of 2. What happens if I do things, again, a little bit differently? What happens if I do the other numbers? So let's see, 0 minus the negative answer of 0.430886938 divided by 0 minus -0.1, we get 4.308 and some change. The same kind of thing is going to happen on this other side. If I get this side, it's going to be 4308. This side's going to be 2. I'm going to test one more number just to prove my point. Let's do -0.001 again, and we'll do 0.001. So if I do the cube root of 8 times 0.001, I get 0.2 and -0.2 is these answers. So let me go ahead and check their slopes real quickly. 0 minus -0.2 divided by 0 minus -0.001 gives me 200. Wow, that got really big really fast. And the same thing would happen if you checked that number. So hopefully you realize that even on this left side, it went from 2 to 4.308 to even 200. So on one side, it's head toward positive infinity. Well, the same thing happens on the other side. So both sides, both limits, head toward positive infinity. Well, that's still kind of nice, is the fact that unlike the last one where it switched from negative infinity to positive infinity, it's positive infinity on both sides. However, this still is an issue. Um, Instead of calling it a cusp, though, I'm just going to say it has a vertical tangent line at this point. The limit goes to infinity. The vertical tangent line would not actually be helpful because that's an undefined slope. So let me write that down. Has a vertical tangent line. Let me write undefined slope. And we'll write that other one down. Limit is infinity. Okay. So wanted to make sure I addressed that stuff. So again, there's 3 really good reasons why we could not have a derivative at a specific point. Number 1, we would have a corner point where it switches from one number to another number. We could have a cusp where it switches from positive infinity to negative infinity, or negative infinity to positive infinity. Or we could have a vertical tangent line where it's still infinity, but it's either positive infinity or negative infinity both times. It doesn't switch. The other possible case where it's not differentiable is, again, where it's not continuous. So just wanted to make sure I got that across. Hopefully this helps you better understand derivatives in general. If you have any questions, please feel free to ask me. Have a great day.